Uh, Thanks for having me. So my name is Matt Lease. I'm a professor at the School of Information here at UT Austin up the road. Whenever I say School of Information, people don't know what that is, so I always have a slide first to say something about it. So I'm a computer scientist by training, but at universities we have these departments like psychology and computer science and biology, and they all do different things. They don't really talk to each other often very well. So these schools of information have started to be found at a lot of universities around the country to really be interdisciplinary centers. So I'm on a faculty of 20, and we come from 13 different disciplines in there. So particularly for my part, I'm really looking at this intersection between traditional computing, so I do machine learning work, as well as sort of interaction with people, so human-computer interaction. And so when I talk about stuff like crowdsourcing, we have questions like, how do we design tasks that people understand how to do? How do we motivate them to want to participate and perform well? And we're going to balance that both with machine learning on the back end to reason about the quality of the work people do. So the talk for today is going to be very short and fun, hopefully. So what I'm calling crowd computing is this mashup of crowdsourcing and human computation. So crowdsourcing means a million different things, but I'll be more specific as we go in. But in particular with regard to machine learning, we're really looking at sort of a place where if you want to have competitive supervised learning algorithms, you just can't get enough data through traditional means to compete anymore with sort of state-of-the-art performance. So there's been a huge gold rush out to going to online contributors to do data labeling in order to really get sort of state-of-the-art accuracy. And that's what I sort of call the first wave of crowdsourcing. The second wave has been this move towards human computation, so actually integrating crowds with your algorithms at runtime. And the reason you want to do this is because there might be certain capabilities, an application, a mobile phone app you want to build, and state-of-the-art AI isn't good enough. So, I go to my conference each year, and we get 1% improvement next year on our given task, and we feel really good about ourselves. But that doesn't help if you can't still build the application today. So the cool thing is with human computation, we can actually integrate crowds into the application at runtime and sort of deliver arbitrary level performance. And so as AI gets better over time, we can back off from using the crowd, but we can actually think about sort of building science fiction kind of applications today, even if AI isn't good enough to do them. So I'll give you some examples about that as I go forward. So get started. This is basically what I've said for the first part. So what was been called the unreasonable effectiveness of data is this sort of joke that we would be better off in doing our research in computer science if we would stop paying graduate students to come up with algorithms and instead just pay them to label data for the 6 years they're there for their PhD. Because data is sort of the most important thing. Data is king for sort of getting performance. So we used to do all these little experiments down here at our toy data scales and compare our algorithms and feel good about ourselves when we got something that was great. Then the problem was we started looking at what actually happens when you have lots of data, particularly if you're going to have a task that operates at scale. And it turns out this algorithm that did so good here doesn't actually necessarily perform that well when you go up to large scale, if you can even run it, because it might not scale up to that. So we really realized that you have to look at this sort of stuff at the scale you have it, the scale of data that's available. The second motivation, to give you a concrete example, I'd like to take a picture of my dinner plate and know how many calories is there, because I'm watching my diet. And I can't make a computer vision algorithm to do that today. But I can actually make an application using crowds that you can do this. And the person using it won't necessarily even know this is happening behind the scenes. Okay. So there's a couple motivations. So crowdsourcing. This term came from Jeff Howe, for anyone who doesn't know. He wrote a two-part article in Wired back in 2006, and then would later go on to write a book. And it's sort of a meta term for sort of taking any task that was done sort of by a traditional known agent and advertising it via an open call. So sort of letting people outside your organization come and participate. And I often show a slide I've cut today that shows like crowdsourcing means a million different things. Like for some people it just means crowdfunding. So raising money like Obama did so successfully several years ago. So in this context, what I'm going to talk about is sort of this very narrow computer science version of crowdsourcing, where Mechanical Turk is sort of the service that's best known by people. Who has heard of Mechanical Turk? Awesome. Okay. So what's funny is like Mechanical Turk launched a year before Amazon got into cloud computing, but like everyone knows Amazon's cloud computing, and lots of people actually don't know Mechanical Turk. Great. So you guys know this pretty well. So the one point I'll make is like when Jeff Bezos was launching the service, one of his taglines for this is You've heard of software as a service. This is human as a service. The idea that actually, not just that this is a Craigslist and we get people to do cheap work at scale, but the fact that we can actually integrate people via an API into our software applications. I want to quickly say, I don't necessarily endorse Mechanical Turk as like the best service to do everything. So there are lots of other platforms out there. We've done research looking at trade-offs between different platforms. So I'll talk about Mechanical Turk in this talk, again, because it's the canonical one, but there's lots of other services you could use to do this kind of work. So 2008 was sort of the year that I think of really being the gold rush where this took off in computer science. So you can look across different areas from information retrieval, human-computer interaction, natural language processing, what's the last one I have, maybe computer vision, where suddenly everyone discovered, oh my gosh, I can get so much data so cheaply, and I can get much better performance on my machine learning algorithms. And the common trend we saw was, well, if you took it like the level of accuracy that your original graduate student got labeling, if you take 2 crowd labels by some random people in the world, they might not be as good. But if I start taking a greater number of these labels, have multiple people do the same task, and I aggregate their responses, then I can get very high quality labels enough to train my systems accurately. And this is, to overly simplify things, this is still where a lot of the computer science research is today, which is just basically just go out, get crowds to label data, train up a machine learning algorithm. There's been probably the most studied problem in sort of crowdsourcing research has been when I get those 5 labels, how do I aggregate them in such a way to have the best consensus label? So there's been hundreds of studies published on this, and we've done some research as well as some benchmarking of methods. And so there are interesting things to do in this space, but I want to try to push people to sort of think beyond this in case folks are already familiar with this kind of model, but maybe haven't thought so much about using human computation more directly. So human computation is not a new thing. This is a picture from the Works Progress Administration, actually under FDR, where, say, they had people, often women, doing calculations. And they would basically say, I want to know cosine of some particular value. And they would have 2 algorithms for doing it. And people would follow one algorithm in one room and one algorithm in another room. And they would carry their sheets of paper to a 3rd room where somebody else would check it and sort of get the right answer. So human computation has a long history. It's just that we were able to automate a lot of it. And so we stopped using people to do this stuff. But there's some sense through which we sort of like threw out the baby with the bathwater, which is to say there are still important things that state-of-the-art AI can't do that people can. And we'd like to take advantage of that, but we haven't been able to until we have things like the internet and Mechanical Turk that make it suddenly easy to actually integrate people alongside AI at runtime. So here's one example of this that's sort of a bit close to this traditional case we were looking at. So let's say you're going to have some camera up here monitoring the bar, and you just want to know how many glasses are there that need a refill. So we can train a computer vision algorithm up to do this. But let's imagine you might start and you might not have any training data to begin with. So how do you get started on this? Well, you can make this a crowdsourcing task right away, put it out there, show a picture, ask people how many glasses are there, and you can start collecting training data. So from day 1, with no training data, you can ship an application that works, that people can get results on. And as you start collecting more and more training data, eventually you'll have enough that the machine learning algorithm gets good enough that you can stop using the crowd. So this is cool because, again, you want to launch into a new area, you want to be agile. You don't have to wait to go collect a bunch of training data. You can launch from day 1 with just the crowd and then switch over to machine learning over time. Now, on the other hand, let's imagine that you're taking this picture of the bar, and then at some point, one of the light bulbs goes out, or the lighting changes. Suddenly, this throws off the computer vision algorithm. So you have sort of a non-stationary distribution between what the situation was like and what is going forward. People are very robust to this kind of stuff. They won't be thrown off in answering the question, but suddenly your machine learning algorithm is probably going to break. So if you are all the time while you're running machine learning also sampling out some of the examples to the crowd for responses, then you can also detect when something's changed and the machine learning is broken, seamlessly switch back, fall back over to the crowd, keep collecting data in the new condition until machine learning catches back up again, and then gracefully come back over. So again, you can think about, even if it's something that machine learning AI can do today, thinking about using crowds to bootstrap up faster, or to be more robust and to sort of transition back and forth. But let's think a little more beyond this. So when Amazon was launching this service back in 2006, they wrote this sort of visionary article, which was actually really ahead of its time. But it's sort of like, we've traditionally been constrained in building our software applications by what AI can do. But if we could actually incorporate human intelligence into our applications, imagine what we could build. And so we could suddenly imbue software with human intelligence today. Again, this is the important thing. We can do this today. AI may get there eventually, but I don't want to have to wait till eventually to build my app. I want to build it today. So here's this example we just talked about, right? I can take a picture of my dinner plate and through some clever workflow design, have my crowd provide answers such that I can deliver this application today. So let's look at some others. So there's an application for blind people. You might know of one that's become more popular since then called Be My Eyes. But essentially, somebody can take a picture of what's in front of them and say, is this the can of corn or the can of beans or something like this for arbitrary questions. Now, if anybody here is following computer vision, you might know that with a combination of deep learning and visual question answering, this is the kind of thing that is now the rage that computer vision is trying to automate. But they are absolutely not there yet for doing arbitrary questions. Here you can ask arbitrary questions about a picture, and this is actually helping a portion of our disabled population be more functional. When Amazon launched the service, they of course would like to make money off of this. And so here is this cute idea. Well, okay, I'm at Target or I'm at my friend's house and there's a chair, and that looks like a great chair, but I wonder if Amazon has it cheaper. So I'd like to take a picture of the product right in front of me and have it matched up to Amazon's catalog. Now, scanning barcodes is pretty easy, but like matching arbitrary pictures where they could be rotated, they could be at different scales, they could be partially occluded, there could be noise in the picture, there could be poor lighting conditions. All this, again, is sort of hard for computer vision necessarily to do well. But what you could do is have the picture go up to Amazon, use computer vision to narrow it down to maybe the set of the top 10 most likely candidates, and then have the crowd come in and filter out down to the right one very quickly at the end. And so this was actually, again, an application that Amazon built several years ago. So a fun story I like to tell is one of my PhD advisors when I was a graduate student was giving the keynote talk at sort of the annual conference for computational linguistics. And he said, well, think of Microsoft Word. We've conquered spell checking. We've conquered grammar checking. What's the next problem for the frontier? Automatic ethics checking. Think of what we can do. And the point was this was a joke talk. This was not serious, right? Because of course we're not going to be able to automate ethics checking. But suddenly, like this joke, this sort of science fiction thing, is sort of not so crazy. So there is now a plugin for Microsoft Word you can get. It doesn't do ethics checking, but it does automatic document summarization. So you have a 20-page document. You can basically summarize it down to any arbitrary length from a paragraph up to 20 pages. By using crowds, they will take your document, chop it up into pieces, ship it around the world, have people summarize parts, put all the pieces back together, and give you a slider bar to move it to any arbitrary length. That's pretty cool. And again, I have a history of working in natural language processing. Automatic summarization, we're absolutely working on it. We're trying to get it better. But we can't do that today. But I can make this with a crowdsourcing application that works. Here's another one. I like to be able to translate between languages where essentially I don't have enough bilingual speakers to provide training data for machine learning, and I don't have enough bilingual speakers to even perform the task manually. So can I do translation between languages with monolingual speakers? How would that work? So I start with, say, a sentence in English, and I'm going to pass it through really bad automatic translation to, say, Swahili. Thank you very much. So Swahili. And I'll have a native Swahili speaker who can say, is this a good Swahili sentence or not? And if they say, yeah, it seems like a fine Swahili sentence, then maybe I'll believe the translation is OK. But if they're like, no, it doesn't make any sense, then say, well, can you change it into another Swahili sentence that you think does make sense? And then we'll take that and we'll pass it through the machine translation back over to English again and ask the English speaker, does this mean the same thing as what you said to begin with? And we can keep doing this sort of back and forth. So combine sort of a crappy machine translation system with monolingual speakers to do translation between arbitrary language pairs. And so they're using this to try to translate stories like Goodnight Moon for children into all possible languages on the planet. This was a paper that was just at a conference last year, which is pretty cool. What I like about this is a lot of the story I'm telling you so far is, well, people can do stuff perfectly, but AI falls short. How can we use people better? This is a story where actually people fall short and AI falls short, but if we put them together, we can do better than either one. So I want to know how many people there are in this picture. So if there's like 10 people in the picture, like we're good at counting that. If there's more than that, we start to get confused, right? How many have we counted so far as we've gone along this list? So people have a hard time actually counting once the number of people to count or number of objects to count in the image gets large enough. An image like this has so much going on that it's hard for computer vision also to count accurately. So for the computer scientists in the audience, we learned about things like divide and conquer and recursion, right? How does divide and conquer recursion work? You take something, you break it down into a smaller case, you ask if you've met the base condition or not, and you divide it down further. So think about this. If there's few enough people in the picture, people can count it accurately. If there's too many people, then they can't. So what I do is I'm going to take this picture and just keep dividing it in half and ask people the question, are there fewer than this many people in the picture? And as soon as there are, I have the base case. I can take the counts for all the separate subpictures, put them back together like I typically do in recursion, and now I have an answer for this. So I can use computer vision maybe for the parts that are small enough and simple enough. I can use people once I've carved it down small enough, and I can put the answers back together. So we can think about things like dynamic programming and greed and recursion, not just with silicon, but with human computation alongside automatic algorithms. Here's another application. I'd like to do real-time transcription, say, of television with non-experts. How could I do that accurately? Well, one simple thing is, I'll just get 10 people to all transcribe this thing at the same time and just aggregate their transcriptions together. That does actually reasonably well. We do some algorithms from computational biology to sort of do sequence alignment and put their things together. But the problem is people tend to get confused and stuck and miss the same parts. So here's a cute thing you can do in the design. What you essentially do is slow down different parts of the transcription for different people as it goes through and assign some incentives or point bonuses such that people get more points for sort of getting certain parts right. So therefore, we use that to focus human attentions on different parts of the conversation while it's happening. And therefore, we can get a much higher quality transcript to put this back together, matching sort of these professional transcribers at far less cost. And one thing, of course, is the cost savings, but the other thing is there actually aren't just that many. It's remarkable how few there are of these people who are these professional level real-time transcriptionists. So a lot of this story with crowds isn't just the quality we can get, but the fact that we can scale out to support so many more things, that just when experts are the bottleneck and there aren't enough experts to do something. Has anyone heard of Foldit? Cool. What is Foldit? Anyone? Yes. Yeah, I don't know if a computer learns. That's actually a good question. So, the computational biologists, they're trying to figure out what's the lowest energy state these proteins can fold into, and they have lots of ideas about how to do it, but they don't quite know the answer themselves. And there's lots of algorithms they've come up with, but they don't sort of have the right idea about how to use the algorithms in combination. So put together what computers do well, like lots of operations that are simple very quickly, and human creativity and how to combine those things. If you take the algorithms, make each one of those algorithms basically a widget in a game, and instead of saying something boring like low energy state, call it high points, make it a game for people to play, and people now combine these different algorithms along with their own creativity in order to find sort of lower energy states. And so gamers playing this actually were able to find sort of a lower energy state of this protein that's involved in explaining HIV function than the scientists knew before this. So here you see an example of both gamification being done usefully, as well as a chance, again, thinking of people not just as reproducing the same thing that computers do, but actually using our different strengths, the creativity of sort of people alongside sort of the scalability and speed of computers. How am I doing on time so far?
Go 7 minutes.
Okay, so I can I don't have very much more, and I can sort of add more if people don't have questions, but I'll finish up and actually just take time for questions if you guys have them. So what's the road ahead look like? Where are we going from here? Well, if you're interested in knowing more about this, there's a great opportunity for you. I'm organizing the Human Computation Conference here in Austin this coming fall. And so we'll have all the sort of research going on there in case anyone actually wanted to submit or sort of attend for research. But we'll also have an industry track at the conference. And so for this industry track, there'll be a chance where you can just submit abstracts and talk about cool stuff that you're doing with crowdsourcing. You can, of course, attend and kind of hear about what the researchers are doing, but also what other companies around town are doing. Well, we also tend to get sort of participation from folks out of town as well. Or you can become a sponsor. So did Matt make it here yet? I didn't see him. So Matt Manning from Information Evolution is actually our chair of sort of local sponsorships and for the industry track in general. So he should be here later today, but you can ask either him or me if you want more information. If anyone is interested in NLP, there's another NLP conference that will also be in Austin this fall, and it comes just after this one, so they don't overlap in terms of their main sessions. Another thing, if you're interested in sort of follow-on work, so I had the opportunity to work with some really cool people from a bunch of different universities. I wrote a paper called The Future of Crowd Work, which is like 18 pages or something. So if you want some time to do some more background reading about sort of crowdsourcing at large and kind of where things are going, this would also be a paper I'd start you with. So again, just wrap up very quickly. So crowd computing is this notion that we can combine both this crowdsourcing, getting people online in large groups to contribute, along with human computation, getting people to perform computations instead of the silicon we traditionally think of, and using people strategically in ways to do this. And that not only can we, say, get state-of-the-art machine learning performance by labeling more data, but that we can actually deliver sort of next-generation applications today. And over time, AI will catch up, AI will get better, we'll shift more and more work away from crowds, but we don't have to wait for that. So this is just my acknowledgement slide, and I think this may be a good time to just take questions.
So you refer to human computation. So the fact that humans do the core work is covered by that phrase, and the fact that the task is parceled out to a variety of entities is the crowdsourcing. The humans are not, in the way they use the phrase, the fact that the work is done by the humans is covered by the fact that it is human computing. And the fact that it is parceled out by some technology is crowdsourcing.
Yeah, exactly. So crowdsourcing, again, is this umbrella term to sort of take any task that was sort of done by somebody you know and advertise it via an open call mechanism. So we can do human computation just like you at your desktop. So I work with Google to do, when I sit down and do a Google search, it's a partnership between me and the search engine where I'm trying to figure out the right queries and it's trying to figure out the right algorithms. So that's a form of sort of, a partnership of human computation, but there's no crowd involved. A difference also is in crowd computing, instead of like me calling on, say, the Google search interface to help me find something, you actually have the software calling on people to help it do something. So crowdsourcing lets us go out and reach a larger set of people to participate and sort of help the algorithm along in places where it's falling short. So yeah, that's how I make the divide. Human computation, humans performing computational mechanisms, and crowdsourcing, which is getting the crowd of people to come participate.
The crowd could be non-human entities. It could be other machines.
It's not usually the way we talk about it, but certainly you could have a distributed computing application. So we've thought of something like MapReduce, where you have a combination of computers doing the parts they can do and crowds doing the part they can do, and sort of an overall runtime that knits them all together. I think you had a question first, and then, yeah.
Have you studied any incentive models for crowdsourcing or whatever? I mean, why would anybody want to do your work?
Yeah, so I've given a number of tutorials on this stuff, and I have many more slides, and I can also point you to resources. But in general, people want to make money, they want to learn, they want to socialize, they would like prestige, they would like to do something good. Those are the top ones offhand I just think of off the top of my head. And we usually distinguish between what we call extrinsic and intrinsic motivation. So extrinsic is like paying people to do stuff, and it's like the easiest knob you can turn, but then people's incentives might not be aligned with the actual work they're doing, and so you might have to worry more about spam. On the other hand, with intrinsic motivations, if people are passionate about contributing to something, then they'll come and just work on their own. You don't have to pay them. And there's no reason, in some sense, for people to try to cheat the system because they care and are aligned with the mission of what it's trying to accomplish. Yeah.
I have kind of a two-part question. The first part is, how do you handle sort of quality of service issues? Like if you want to sort of guarantee that there'll be humans, you know, responding to some query, do you sort of have to over-provision the humans like you do for servers so that you sort of guarantee that you can do that? And then sort of a related question is, can you talk a little bit about costs for the humans in this? Are there certain things that cost more? How do you handle this sort of over-provisioning case?
Sure. So briefly, absolutely, you do that kind of over-provisioning. And besides research, I've been consulting for a company someplace where they're in fact trying to deliver real-time performance on something and looking at sort of the ratio of over-provisioning they need to guarantee certain latency conditions. Or, for instance, quality of work. You know, if I am going to have multiple people do the same task and aggregate their responses, what level of aggregation and plurality, redundant work do I need to do to ensure that I achieve a certain quality of service? So absolutely, that's done. What was the second question again?
Sort of, how much does
what does it cost?
the cost issue?
Yeah, so it's a global economy. So the number that people bandy about on Mechanical Turk, for instance, is something like $2 an hour. But in practice, it varies quite a lot. And so some people are really concerned about providing fair wages. And so they look at, say, what's the minimum wage in a given region, and they try to make sure they're paying that. Other people are just basically saying, when I go and post my task, what's the least I can pay that gets it done? And they don't worry about anything beyond that. So it's certainly, the way I think about this, if I can try to make up a figure quickly here. So, you know, if you think about dimensions, you have like speed, how long something takes, cost, how much you have to pay, and quality of what you can get. And before what we've been in this little box, which is we can get really fast and we can get really cheap, but we were bounded up here like a glass ceiling. Now, I might have to pay more for the crowd, but then I can get higher quality, and I might have to wait longer because, you know, people, as fast as they are in whatever level, in some sense, will never be as fast as the nanoseconds you can get from, say, if you have a very fast algorithm. So that's a bit hand-wavy, but yeah, absolutely, you do have to pay something, and it can vary a lot for those kinds of reasons. Yeah, that's what I was going to say.
Go ahead.
Thanks, Matt, by the way, very nice talk. So following on the answer to your question just now, one of the things that fascinates me about crowd computing is that there's an ethical component too that you just alluded to. Like I've seen at least one, article on Medium, arguing that it's not okay, for instance, to pay people less than $1 an hour for this kind of work or whatever. On the other hand, maybe it's okay if they're genuinely having fun or genuinely volunteering their, mental resources for a good cause. So I'm wondering if there's a way, theoretically, or at least sort of academically, in crowd computing research to operationalize the ethics of the computational question, above and beyond just the simple wages.
Yeah, so this is a question near and dear to my heart, and so I have to just make sure I don't go on too long here. So the metaphor I like to think about is iTunes. So people were all stealing music until somebody came and made a design that they changed the economic model and the user interface in such a way that it was not much more effortful to sort of behave ethically than it was to when it was to not. And so I think perhaps cynically, many people are going to be motivated by bottom line, and fair trade, sort of as it is right now, is going to be sort of a lesser number of people that are actually going to be really concerned about that. So I think to have a large impact, I've tried to look at ways, for instance, that say when you go to post your task in Mechanical Turk, I can have a plugin that will tell you, well, for the region of workers where you're getting, this is what their pay should be, and make it as easy as possible for you to have the information about what appropriate pay should be, and hopefully that will help you make decisions that are more aligned in that case. So there's absolutely research in ethics, and one thing I like to tell my computer science friends is, in the Association for Computing Machinery, which is one of our biggest professional society, we all have a code of ethics we sign as part of that, and as part of that we need to reason about things like what's the costs of outsourcing when we're buying computers remotely versus that. So, the code of ethics is for us all to do good, and I'd like us to think about good not only in terms of the applications and services we deliver, but on the impact of the people who are doing the work. So I think in some cases this is a great opportunity for economic mobility in regions of the world that are repressive or stagnant in terms of local economic opportunities. On the other hand, I think can also be exploited, and this is something which we need to really talk about. I appreciate the question.